There you are. Hi, my name is Patrick, but you can call me 26. And what we're going to do today is we are going to finally find out between lists and LazyVStacks, which one are more performant in SwiftUI. Look at what our test is going to be. So we're going to have a struct, and the struct is just going to have a number item, and we're going to have an ID in the number item so that we can use the for each when we're looping over it, right? So it's going to have the ID. Then the number item, the number is just going to be a view. For the numbers, we're going to have a view model, and the view model in question is going to have a collection of numbers between 1,000 numbers between 1 and 1,000,000, and we're going to make sure that they're unique, right? So we're going to check and put them in a set and make sure all of them are unique. Afterwards, we're going to put them together. Now, because we know that lists and LazyVStacks might not always want to keep track of the various differences, and we do know that underneath a list is just a UI table view if you're coming from UIKit. Keeps track of the numbers is different, right? How it keeps track of all the numbers is a bit different. What we want to do to check the diffing is we're going to have function to shuffle the numbers, right? So what we're going to do in this example is, and we're going to test it a number of times, we're going to start the application, right? And then we're going to scroll all the way to the bottom of the 1,000 numbers. Then we're going to shuffle them, and then we're going to scroll back up. And in all this time, we're going to check what is the maximum amount of memory that has been utilized for this, right? So what you're going to do is, because there can be a bit of difference when we, can be a slight difference when scrolling, right? Maybe you don't hit the mouse wheel right, maybe as you're scrolling there's a certain issue, right? And we're using the simulator. What you're going to keep track of, and what is going to be a fairer view, is going to be to use the maximum memory consumed by the phone to do this, right? So you're going to have 1,000, which is pretty big but not big enough to tax the phone, right? So you're going to have 1,000 in the list, and then we're going to have the list, and then we're also going to do the LazyVStack, and then we're going to compare and see which of the two consumes the least amount of memory, which of the two has less memory overhead when you start off, right? So let us do that. Obvious, we are going to be doing it on the simulator and not the preview, right? Just to make sure that it works best, right? So we're going to use the simulator and not the preview. So let's do that, right? So we have our content view with our navigation stack, and right now we're going to have the list, right? And then later on we're going to change to the scroll view, and you're just going to loop for each, have the word number and then the actual number next to the number, a bit of padding, and then we're going to call this when the view is shown. So that's going to be we're going to call the view model, which is the VM here for the number view model, and then we're going to call the function generate random numbers, right? And then in the toolbar at the top here, we're going to have a button for shuffling the numbers, right? So we're going to shuffle the numbers. And at the end of all that, we're just going to make sure that we keep track of all the actual performance, right? So let us actually run it and see, right? So let's just hit this button and start the simulator. And the simulator is starting. Give it a second. And we do have the simulator here. And we can see the memory. And when we start, let's give it a second, it's now starting. Let's look at the maximum, let's look at the memory and see what's the worst memory, the maximum memory. So far it's been 26. And I'm going to do it 3 times and then compare the average of the 3, right? Then you're just going to plot them and see, right? So the average, right now it's going to be 26.7, and let's just confirm. This is 26.7, and it's going to be for the actual list, right? We just have a list here. So we have 26.7 as our memory, 26.9 actually, as the worst memory that we have had. We have not scrolled, we have not done anything. Let's scroll to the very bottom. So I'm going to scroll to the bottom, and we see the maximum that we hit. So when we scroll to the bottom, the maximum memory we have, the memory high has been 34.5% megabytes, rather 34.5 megabits. And if we shuffle them and then scroll to the top, let's see what's the maximum memory that you're going to hit, right? We have hit 35.2, and let's just scroll up and see the maximum that we have hit for the memory, and it's gone to 35.8, and the maximum memory so far is going to be 35.5, right? 35.9 to be exact, right? Not here. 35.9 is the maximum memory. This is after shuffling, scrolling all the way down, and then shuffling, and then scrolling all the way up. Now let's switch it and see how the LazyVStack works with the same test. We have our LazyVStack in our scroll view so that you can scroll. So we're just going to run it, and we're going to see the amount of memory consumed, right? So it started. Let's go to memory and see it in particular. And so far, the maximum memory used has been, even before we scroll, is about 25.5, right? So it's 25.5. And that's it, right? So it's 25.5. And remember the other one got to about 35 point something, right? So what we want to do is we want to scroll to the bottom of the list. So let's just scroll and make sure you get to the bottom, right? And get to the bottom and see. And we can see that it's consuming less memory than the highest it has gotten to is 26.9, right? So we find that it's actually consuming less memory than the actual list, right? Now let's shuffle so that we can keep track of the various, it will try and keep track of the various elements. So we hit shuffle and it jumps to 27.4. And now let's scroll all the way to the top, right? And see how it does, right? 28, 29, it hasn't hit 30, right? So already we can see that this list vstack, right? Vstack is more, LazyVStack is more performant in terms of memory as compared to list, right? But what I'm going to do to make it scientific, I'm going to do both of them 3 times. Try it out 3 times, get the average, and then for both when you start it and when you scroll to the bottom and get the, what's it called, and shuffle them and then scroll to the top, right? I'm going to get the average of all 3, right? And then I am going to compare the 2 of them, and we finally come to a conclusion that between a list and a LazyVStack, which one is more performant? So we have average times. I plotted 5 times. I did it 5 times, opened and did the shuffling and then scrolling 5 times and then compared them. And we find that on average, the list takes, opening it takes 28.77 megabytes to open it. And the LazyVStack takes 25.4, that is just opening it. The average for scrolling plus shuffling, the memory consumption on the list, let's just scroll, right? The memory consumption for the list is going to be 37.0, and the scrolling plus shuffling on the LazyVStack is going to be 28.3, right? So when you compare the 2 between opening it and scrolling, you find there's even a bigger difference on averages, right? So on average, you consume a lot more memory when you're using the list, and even between the various times, right? Even after you open, the memory consumption still goes high, right? Increases as you use it, and this is not the case for the LazyVStack. I'm guessing that the lower initial footprint of the LazyVStack is because it doesn't come with a lot of the inbuilt things that the list has. Because the list is basically a UI table view, that means it has things like swipe actions and other optimizations that are available for it that if you are going to use the LazyVStack, you do not have, right? Like you list off with very little code can give you things like swipe actions, right? So this end up having a higher initial memory footprint as compared to the LazyVStack, right? And also we find that it has, the LazyVStack has better memory efficiency during the interaction with the scrolling, plus also the shuffling of stuff around, right? And the difference between the opening and after scrolling and shuffling, the difference isn't much, right? You can see the average here is about almost 3 megabits, right? Between 25.4 and 28.3 as compared to 37.0 and 28.77, right? That's 9 more megabits. And here we only have about 3 more megabits, right? So overall, the memory advantage is for the LazyVStack in both scenarios, right? LazyVStack would be a preferable choice when you are particularly interested in data critical apps where memory consumption is a big concern. Maybe if you're dealing with a large data set or you want it to run smoothly on devices. If, for example, you are supporting very old phones that have lower devices, right? If you're dealing with the iPhone 7 or something like that, or however far you can go back when you are watching this, right? So if you're doing that, consider using the LazyVStack because it is less taxing on your memory, right? Now, for the list, what I can say is that because it potentially uses the UI table view and the sale management and the preloading strategies, it is less optimized for memory in dynamic scenarios as compared to the LazyVStack, which uses a lazy and a more on-demand approach. The conveniences, now what you have to decide is whether the conveniences of using the list outweigh the hits or the increases to memory, right? So that is it. Thank you for watching, subscribe to the channel, and I'll see you in the next video.